Hello and welcome back to Caroline's Chemistry. In today's video, we're going to demystify writing ionic formulae, another GCSE Chemistry favourite that causes more hassle than it should. I'll show you how to work out the charges on ions, balance them correctly, and write perfect ionic formulae. We'll tackle all the awkward bits examiners love, like ammonium ions, hydroxide ions, and those sneaky transition metal ions with Roman numerals. By the end, you'll have a foolproof method you can use in every exam question, so you'll never lose marks here again. Make sure to subscribe if you haven't already, and let's get started. So we use ionic formulae for ionic substances. And if you need a quick recap about how to identify them, what their structure type is, and what their properties are and how to explain them, then check out the other videos that are in this channel, and I'll sort that all out for you. Here we're focusing just on how to write those ionic formulae though. And we're going to start with, how do you work out the charge on an ion? Well, it depends on their position in the periodic table. That's where we're going to start. So what we do is, say for instance, you have iron oxide. You take the iron and you say, where is it in the periodic table? And the position of that metal will tell you about the charge on the ion. So for instance, if it is lithium, sodium, potassium, all of those are group 1 elements. And what that means is they have 1 electron in their outer shell. In order to get a full shell of electrons, therefore, then group 1 elements will lose 1 negative electron. But they still have the same number of positive protons in the nucleus. So if they've lost 1 negative charge, 1 electron, it means they have 1 more positive than negative, and therefore group 1 make 1 plus ions. And then the same logic applies to group 2 and group 3. Group 2 have 2 electrons in the outer shell, therefore losing 2 negative charges, 2 electrons for that full outer shell, so they're plus 2. Group 3 have 3 electrons in their outer shell, they are losing 3 of those negative electrons, so they are plus 3. Now let's think about groups 6 and 7. Now, group 6 elements, they have 6 electrons in their outer shell, and in order to get a full share there, they need to gain 2 negative electrons, which gives them a charge of -2. Group 7, they have 7 electrons in their outer shell, they need to gain 1 negative electron, so they have a charge of -1. So the position in the periodic table, group 1, 2, 3, 6, and 7, tells you the charge on the ion. And you might be thinking, well, what about groups 4 and 5? Why aren't you mentioning them? It's because they do not tend to make ions. They tend to be involved in simple molecular substances, for example. Now, there are some ions, however, that we do just need to learn. You can't figure them out from looking at the periodic table. Now, these apply whether you are a GCSE or A-level student. So the positive ions that you need to know and remember, one is the ammonium ion, NH4+. Now, key thing with that, don't make this mistake because I see it a lot, is people get confused between ammonia, NH3, and ammonium, NH4+, the ammonium ion. Now, the way that I remember that, so ammonia, NH3, has 3 M's and N's, AMMONIA, whereas the ammonium ion has 4 M's and N's, and that's how you can remember if it's NH3 or NH4+. If that doesn't help you, don't worry, you can forget about it. The other way to remember them is get these all on flashcards. You can check the link below for my ionic formulae flashcards. The next one is hydrogen. So hydrogen, it has element number 1, so 1 electron in its outer shell. In order to become an ion, then one way that it can do that is to lose the only electron it has, and therefore that becomes H+, a 1+ charge. We then have the hydroxide ion, OH-, nitrate ion, NO3, with a charge of 1-, the sulfate ion, SO4, with a charge of 2-, and the carbonate ion, CO3, with a charge of 2-. Those just keep practicing until they are in your brain. Now here's the key idea. In order to write an ionic formulae, the number of positive charges must equal the number of negative charges. And in order to do that, the only thing you can do is change the number of ions. You cannot change the formula of the ions itself, meaning like the hydroxide ion is always OH minus. You cannot change that at all. Ready for my terrible joke on this? Sorry in advance for this one. A guy walks onto a bar and he orders a glass of H2O. A second guy walks into a bar, sees the first guy sipping his drink, and goes, oh, I'll have H2O too. The second guy dies. Why? Because H2O is water. H2O2 is hydrogen peroxide bleach. So you change the formula, you completely change the substance. And that joke is meant to like show you or point out that you cannot change the actual formula. Like a sulfate ion is always SO4 with a charge of 2 minus. That bit you cannot play with. The only thing we can do is change the number of ions. Do we have 1 hydroxide ion, 2 hydroxide ions, 3 hydroxide ions? I'm going to show you what I mean by that too. Okay. The other common mistakes are in how you actually write the formulae. So capital letters need to be drawn as capital letters. And I'm really sorry that even though you might have like a handwriting style, which means that you style a certain letter a certain way, that's just natural to you, you have to draw your letters exactly as they are shown on the periodic table. So for example, F for fluorine, it needs to have a straight top on that F. Lowercase letters should be shown as lowercase letters, again, like they are on the periodic table. Don't start messing with the way that those look. The numbers, when you're writing an ionic formula, should be what we are calling subscript. So a subscript number is a little number and it's to the bottom right. And I've shown you an example there, like X little 2 in that bottom right-hand corner. And learn the ions that you need to learn.
So aluminium is in group 3. That means it loses its 3 outer shell electrons and becomes Al3+. Fluorine is in group 7. That means it has 7 of its own outer shell electrons. It needs to gain 1 negative electron, so it's therefore minus. Now the only thing you can do here is change the number of ions. So if we have 3+ over here, then we can add another fluoride ion, so that becomes 3 + 2 minus, still not balanced. So therefore we add a final fluoride ion. So now we have 3+ and 3 minus. We're going to write down how many ions we use to balance those charges. The aluminium ion we only used once, so we just write Al. The fluoride ion we used 3 times, so we show that with a little subscript 3, AlF3. So next we have sodium oxide. Sodium is in group 1. That means that it needs to lose 1 negative electron, so that it is therefore a +1 ion. Oxygen is in group 6. It therefore needs to gain 2 negative electrons for its full outer shell. So we have Na+ and O2-. Now to balance these charges, we don't have enough positives, so we're going to add another sodium ion. Remember, we can't change the formula, we can't change the charge on the ion. The only thing we can do is change the number of ions in order to get these charges to balance. Now let's write down what we've got there. So we have the sodium, and we've used that ion twice. So we use the little subscript 2 to show that, and then the 1 oxygen ion. So sodium oxide is Na2O. So next we have iron 3 oxide. Iron is Fe. Now the Roman numerals 3 tells us that the charge on that ion is 3+. Metals always make positive ions. They always have electrons to lose for the full outer shell. Oxygen was group 6. It needs to gain 2 negative electrons for that full outer shell, so it's O2-. Let's try and balance these charges now. So we could try add another ion. And that makes 6+. Now to balance the charges, let's try adding oxide ions. So there we have 6+ and 4-. Let's try adding another one. Now the charge is balanced. 6+ and 6-. Let's write that down as a formula. So Fe2 2 because we use 2 iron ions, and we use 3 oxide ions, Fe2O3. Now we have sodium carbonate. Now sodium is in group 1. It loses that 1 negative electron and becomes a 1 plus ion. The carbonate ion, however, that's one of the charges on the ions that we just have to learn. You can't work that out from the periodic table. Carbonate means carbon and oxygen, but that as an ion, CO3 2-, we learn that one. Next, in order to balance the charges, we need another sodium ion. Now we have 2 plus and 2-, they cancel out. So to combine those, we use 2 sodium ions, so Na with a little 2, but only 1 carbonate ion. So we just write that as is, Na2CO3. Zinc, we're told, is a 2 plus ion. Those Roman numerals mean it has a charge of +2. The hydroxide ion, that's one that we learn. So we learn the hydroxide ion as OH-. So to balance the charges here, we have 2 positives, but only 1 negative. So let's add another hydroxide ion. Great, now these balance, 2 plus and 2-. In order to combine these now, we used 1 zinc ion and 2 hydroxide ions. But we want to say we have 2 of this entire thing. So if I just put a little 2 like that, as it reads now, that means I have 1 zinc, 1 oxygen, and 2 hydrogen. That's not what I'm trying to say. I'm trying to say I have 2 of this entire thing. So we add in some brackets to show that we have 2 hydroxide ions. So that formula is Zn brackets OH brackets 2. Iron is Fe. Those Roman numerals mean that it has a charge of 3 plus. The sulfate ion, that's one that we need to learn the formulae of. So it's SO4 2-. Now we need to try and balance these charges. So let's change the number of iron ions. Fe 3 plus. That means in total now we have 6 plus. Now let's try and balance these negative charges. Let's add another sulfate ion. That gives us 4-, not quite there. Let's add a third sulfate ion. Now we balance 6 plus and 6-. To combine those into a formulae, we're going to write the Fe, and then to say that we had 2 ions there, we put that little subscript 2. Then for the sulfate ion, SO4, we're trying to say we have 3 of this entire thing. So again, we're going to add brackets and put the 3 outside, meaning everything inside those brackets is times by 3.
So here's a chance for you to practice without me revealing the answers straight away. You're going to need a periodic table in front of you if you don't have already. So have a go, pause the video, and when you have done them, press play again and we'll go through the answers. Okay, so here are the answers. Again, pause them if you need a little bit more time to peer at the screen and check them out. If you have questions about any of these answers and you're not sure why these formulae are what they are, leave a comment below this video and I will answer any and all questions that you have about each of these ionic formulae.
Thanks for watching, and if this was helpful to you, don't forget to hit subscribe right now for new GCSE and A-level chemistry videos every single week. I look forward to seeing you in the next video.